I'm Pamela Davitt with Guard365, and today I'm presenting a demo of Endpoint Detection and Response. We'll begin by going over and looking at what the Sentinels see in this test environment with only a single system in there. It shows us the visible IP. It says this is Tom's test. It's a special group because we're going to be changing some policies in there, updated 4 minutes ago. January 2nd is when I registered this current setup. It's healthy. It's a desktop running Windows 10 Pro, 64-bit, 8 gigs. It gives us great information about the endpoint. We know the MAC address, we know it's online, it's connected, we know everything's up to date, and when one of the last full disk scans was run. It works in much like a normal antivirus in some ways because we have features. We just want to scan all the files on there because we have static threats. We have threats that are determined through behavioral heuristics. And finding those is important because we may find something in there. They're good to go through once in a while because they're not actively looking at things. They're just statically sitting on the system. We can click on the system itself, brings up a little window down here to summarize it, and where we can go and look at the app inventory, any tasks that we have queued up for it. We can go to the action recently used to do things like fetch logs, enable different features, agent, edit the custom identifier, and everything can be pretty simply done right here. One of the other cool features we have under Endpoint Actions is that we can approve, reject, uninstall, reboot, and shut down. So it actually works a lot like an RMM tool, remote management and monitoring, where we can directly access the system and have actions done on it. So it's easy enough to do. Also, if for some reason it would be weird to do this, but we can move this to another site. We group different sites together because we're managing many different businesses. So we have them all grouped together under their respective account that we consider policies and actions based on customers. But we can actually move it between them as well. We can revoke, randomize, migrate, agent, approve local upgrade, do the agent upgrade. Among the other things that are kind of neat that we can do is host isolation. So if we think a host has become problematic, we can isolate it to where the only thing it can talk to is the Sentinel and our SOC dashboard. This means that other devices on its local network can't even ping it. That computer becomes essentially muted to the internet with one exception, a connection between the SentinelOne product and our Security Operations Center. So we can still do the task of remediation or sorting out to determine what's wrong with that system. Now the other things that I'm not going to dive deep into that we have the option to build out firewall rules of devices, controls like USB and Bluetooth controls, so we can block USB ports. There's a lot of things that are going to be, of course, a big crossover of what we can do with a lot of other tools, but it's efficient. We have them in here when we're focusing on doing threat management and understanding the threats. What do the threats look like? Well, let's begin with incidents, and we can see the history of incidents tracked and documented here. Now, this is where you shouldn't let the sales reps fool you. We always like to say it doesn't have false positive. As a matter of fact, when we loaded Quicken, when it wanted to do an update for one of our clients, it flagged Quicken malicious as well. This is where we have to do some investigation. Take a look at and understand whether or not that tool we're using is a false positive or is a true positive. It's suspicious, and of course this one's a false positive, and then when we go through and essentially mark it as such, it's not going to get flagged again. Now this is common, especially when we have, let's say, an accounting firm we're managing and they have to do an update. If Quicken gets flagged as bad on one system, it's probably going to get flagged on the rest. So if we catch it on the first system and we go and look at it, and I may not like the product, but I don't think it's actually intentionally malicious, then for this reason we will flag it. Then we can say, mark that as benign for everything in the fleet. That way the next person who has to do that update doesn't get flagged as well. And this is what we did with the Ninja RMM update. We're not sure why it did this, but once we did load it on other machines, they reacted as, oh, we've already seen this before. We have a hash for it now. Speaking of having a hash, right here we can go in. I don't have a recorded feature account, but we could open it up and record a future one. We can open up in VirusTotal and then look at some information. Okay, here's how all the other different platforms think about this particular product. It's useful that they keep the shortcuts right there. They generate the hash. all with the goal of making it easy for us to start assimilating knowledge on whether or not something is really a threat, because sometimes we don't know the system starts as suspicious, and we work our way through to discover if this is suspicious, something new that's trying to get through, or is it just another false positive, which does happen, but honestly there's not that many for the number of systems and endpoints we manage, and recognizing how few false positives there are. And with many of our clients from common software, we figure it out on one system and label a false positive that won't flag on all the other systems. Okay, now back to the actual system. Here it killed and quarantined, but our ability to undo that killing and quarantine is over here under the actions. But this is where we can do the mitigate and unquarantine if we want to. We actually just end up recopying the files, but that's why I didn't do it. I wanted to do some playing here to demonstrate. Normally we just unquarantine it and put the files back. Then we go over to explore, and this is where we can dive a little deeper, and it gives me some of the process management. So this is the execution path. What did it do? It took a network action and it contacted this destination IP. So we can see the source IP of the system, 192.168.13.13, that reached out to this IP address here. It was the Ninja ARM Apacher name. Then we have this part that we discovered, the next network it reached out to, the actions. And we can start tracking these out, load more, so we can look at the Ninja bar. And these are all timelines of when it started, process timeline, when it ended from start to finish. So this is at 10, 16, 39 seconds since the whole process was done in quarantine at 5:05. So we can walk through, and this gives me that in data we're looking for in all those points, so we can understand what each piece was trying to do and what the events were that led up to this. All that intelligence data that we're looking for, so we can get a deeper understanding of it, the network actions. Once again, reaching out to the same idea IP address processes into RMM. Now we can also do these other timelines for the entire event of who did what, when. This gives us the history because it's for our team internally more than one of us working with this. Sometimes where we'll start an investigation, dive through it, and now I can see who did what, including my internal users, for how this was done, how this was resolved, how we went through this particular threat and determining what we did. Here's what a real threat looks like. We'll look at it in VirusTotal. Security vendors and one sandbox. Flag both of those. Flag this as malicious. This is just some random malware. Interesting that this is still not being found by some of these other ones. It's also a relatively recent malware, 21 hours ago, to upload it, and there wasn't a lot of stuff on there, so it's flagged malicious by a few things, including Cell 1. We can look over here and read through the threat indicators that attempted to evade our monitoring process. So we have each one of these. We can dive into the meter defense evasion. We can go through each section and start learning more about everything going on with this. We can even go and fetch if we want, download the threat file, give it a password if we wanted to pull it for local analysis. We do that less often. We typically have enough information here to see that we have some type of unsigned originating from Explorer.exe, because I actually did double click on it using Explorer just to try and get this to execute. It's a small piece of malware, and we can go through and we know, kind of see that, yeah, this is probably something that needed to go away. And then for the actions, we can go through and remediate. Now let's actually deploy ransomware on this system. These I'm showing you were all done with the protection enabled on. Here we actually are going to disable the protection and change the mode of operation for Sentinel-1 so we can see what actually happens and what, if a threat gets through, we can do about that. For that, we'll go back over here to Sentinel-1 and over the policies. The way we set the policies is a little obscure, so here's the default group for my NFR licenses. Here's the one designated Tom's test. So we have a few other things that we're working on in demos outside of this particular demo we're doing here. Bad happened. It did its job. Now this would be the closest I can do to a demo, because I tried a lot of known malware and found that none of it got through. That would be fun to demonstrate for you, but on the other hand, unfortunately, or fortunately, we couldn't find anything that got through. That said, nothing's perfect, and occasionally there could be an incident. But so far, for those we safeguards satisfaction rate, and the reason we continue using Sentinel-1 is because it seems to catch everything, which is the ultimate goal. But we're going to put this on there to detect, as in, do not take action. I've actually seen a few people configure their system like this, because I don't know why this is obviously what is going to let the malware through, so we're going to run one of the same malware viruses that Sentinel-1 caught. but we're going to run it in this mode right here. Are we sure we want to save these changes? Yes. Now that we've got this into malicious threat detect mode, let's have some fun. Note, we're in my completely sandboxed system with a handful of files, nothing important, all isolated from any other networks, which is really important. And even though I've been doing this a while, there's still this nervous factor where we're going to detonate the ransomware on a system. Did we make a mistake? Did we make sure this is isolated from anything else on the network, that there are no potential problems that could come back and bite us with production systems? Physically, this isn't even in my building. This is an independent lab I've set up. If we're not sure if we did this right, then we need a second set of eyes to look at it. My staff and I have gone over this to make sure it's an isolated system, and we just warn others that you want to make sure that in fact you've set this up right. Lots of warning. Even for people who are professionals, mistakes can be made, so have someone else double check it. All right, now for the fun part. This is detect only mode. Let's go ahead and see if this ransomware will work. We're just going to run it as administrator, and yes, it does work. It detects that a file execution, a suspicious one, was detected. Let's see what it does. Hopefully this will work for demonstration purposes. Yes, it's malicious running processes, all right. It's all in detect mode, so it's just going through and alerting us of things. Actually, what we'll do is, while this is running in the background, this computer is not incredibly fast. Do we want an empty recycle bin on this drive? No, it's corrupted. That's weird. Well, not weird considering we're running ransomware. I see something on a desktop popping up. There we go. There's a README here. We'll say no again to that. I'm not sure what it's trying to do. I guess we need to say yes. I don't know where files are encrypted and currently unavailable. Well, I don't think they are yet. So let's give it a minute to finish what it's doing.
You can do it remediate if you want. For most part, kill and quarantine, and then you can remediate manually.
There we
go. On how your policies are internally.
Now the files are encrypted. We have to see the document change. Now this makes sense. It's all encrypted and everything's bad. So this is that worst case scenario where everything has gone wrong. And yeah, let's go through what actually happened. We'll break down the incident and how we see it in here. Now this was a false start. It had a decryptor on there and it
immediately
picked it up.
deleted the file. It got rid of it as soon as I tried extracting it. It didn't let me get as far as executing it.
This is important to go back and read incidents. Suspicious things. This is me pulling out the malware, and the suspiciousness is going to be the opening of this particular tool. So when we start exploring what happened here,
nothing really happened. It's like, yeah, well, they tried to do something. Then you try to figure out what the user was trying to do.
Scroll down.
Are you trying to extract this file?
We'll see exactly what happened.
Investigations, and we'll actually do this right here.
Network action. This is like the kickoff event that started this. So this is me clicking on it, and then that
deleted right away as soon as the file getting extracted. It said no. The moment I extracted the file with 7-zip.
So we're going back over here to the threats. This is where all the bigger events have happened. And let's look through a timeline. Go down to Explore. There's all the processes, everything it touched. Hey, look, there's that little README file it created for us to let us know processes had started on this. We can see how we can go through and say, all right, this is the whole event and it's grouping these together, so let us know that this incident as a whole is what happened. And we can expand it out. And yep, this whole system is just broken now because of the ransomware. Here's the part that people want to know about whether it works. So far, we haven't really had ransomware incidents that allowed something to truly get through. But the testing we have done, which we're doing right here, this does work. And we're about to watch this in real time. So we want to mitigate the action, and we know this is ransomware. Do we want to kill it? That seems like a good idea. Normally it would have killed it automatically. And do the quarantine, at least the default levels of protection we should have. Remediate automatically as well as killing quarantine. But let's go ahead and do full rollback, because this is where we tube demo for full rollback. Because we want those files back, and this is definitely a true positive. So we can flag it as just something suspicious. Our positive analysis verdict. Go ahead and throw in some notes right here. Mark as resolved when we're done. Add to the blacklist. We don't really need to blacklist it, but sure, why not? It's already flagged. So we're not doing any normal investigation where it's suspicious, but rather unknown. Yeah, this is ransomware. We're going to go ahead and hit apply incident status, and that's saved successfully. Action successful note was added. Now, what does that mean for the system over here? It's going to take a few minutes is what it means. It's slowly going through and running through those remediation processes, because one of the things we do is keep an eye on the volume shadow copies and try to stop any tools from breaking. Volume shadow copies it. Actually, just use those to go ahead and roll back the system. Terminated process, quarantine malicious files, reverted changes made by the threat. I'll show how we go back over here. Let's look at our documents folder. Documents are now fully back to where they were. Now, there's no guarantee that every scenario will throw a threat actor. One may find a way around it. That's not what we're demoing. We're showing how a known piece of malware, fairly recent version of it, that is commonly out there and able to get ways into the system, can be contained, and we're able to roll it back because we had it turned off. For reference, we'll show what that looks like if we have it set in the other mode. So if we go back over to our sentinels, now that this is a remediated threat, we can look at the incident and quickly see that it's mitigated. We don't have to worry about this one here. We could just mark this one as done because we did take it off of the later process that happened. We did the rollback from that point. So for cleanup reasons, we'd go and fix this one. But let's actually turn this back on to normal policy, and we can see it's still showing red right here because of the last action that happened. And we have some unmitigated things on there, but let's go ahead and do this, and we'll leave it at kill and quarantine. We could do remediate if we want. For most part, kill and quarantine. And then we can remediate manually. This kind of depends on how our policies are internally. So we'll put it on kill and quarantine, save this policy, go back over to the test machine center. We need to reboot to finish. We'll go ahead and reboot, and we'll come back to this, and we're going to execute the same ransomware again, but with the detect and protect, kill and quarantine to show how far it gets with just kill and quarantine turned on. All right, we've rebooted the system. Everything's back to normal, and we want to try this again, but as we notice in the background here, we saved the suspicious threat, and let's go ahead and do an extract and try and run that again. Well, that didn't get me very far. It immediately deleted the file. It got rid of it as soon as I tried extracting it. Didn't even let me get as far as executing it. This is important. If we go back over here to incidents, and we can see it's unresolved, but then again, we have a nice checkbox here because it immediately saw the ransomware again. It said, we're just getting rid of this, and then sent a notice. We have this set up to send notice to our ticketing system. So we would have got a notice on this. But then nothing really happened. It's like, look, they tried to do something that we tried to figure out. What was the user trying to do or dive into? Why were we trying to extract this file? Did it come from an email? So we'll do our investigations right here, and it doesn't find any processes because it was merely a file. But if someone actually tried to even execute the file or click it, it would tell us the application that they tried to click it out of. This deleted right away. As soon as it saw the file getting extracted, it said no. The moment I unextracted a file with ZZip, it immediately killed it. And that's the end of the story.